Ever wonder how big our universe is? Let's start with our home, the Milky Way. Our galaxy, the Milky Way, is far from being a small corner in the cosmos. It's a sprawling cosmic city in its own right, spanning approximately 100,000 light-years in diameter. Now, if you're wondering what a light-year is, it's the distance light travels in a single year, which is about 6 trillion miles. So, imagine a beam of light speeding away at a rate of about 186,000 miles per second and let it run wild for a whole year. That's 1 light-year. Now multiply that by 100,000. That's the diameter of our Milky Way. But here's a twist. Our galaxy is just one of the billions that exist in the universe. It's like one grain of sand on a vast cosmic beach, or a single note in a grand symphony that's being played across the fabric of space and time. Each of these galaxies contains billions of stars, many of them likely hosting their own planets. In our Milky Way alone, there could be as many as 400 billion stars. That's a lot of cosmic real estate. As we consider these staggering numbers, remember, we're only talking about the observable universe. That's the part of the cosmos we can actually see from our vantage point here on Earth. Beyond the reach of our most powerful telescopes, there are likely even more galaxies, stars, and planets. So our galaxy is vast, but remember, it's just the start of the cosmic journey. We've only just begun to peer into the depths of the cosmos, and there's so much more to discover. So, buckle up, space explorers. We're in for a thrilling ride through the universe. Beyond our galaxy, the observable universe stretches even further. This vast cosmic landscape, which we've only just begun to explore, is estimated to be about 93 billion light-years in diameter. Now that's a number that can really make your head spin. Within this immense expanse, there are billions of galaxies, each one brimming with billions of stars. That's right, billions of galaxies, each with their own unique collection of celestial bodies, cosmic dust, and dark matter. It's a cosmic dance on a scale that's hard to fathom. To put it into perspective, if each galaxy were a grain of sand, you could fill an Olympic-sized swimming pool, and then another, and another. And yet, each of those grains of sand, each of those galaxies, is a world of its own with a unique story to tell. But here's something even more mind-boggling. The universe is still growing. That's right, despite its already inconceivable size, the universe is continuously expanding, pushing the boundaries of what we can observe further and further away. This expansion is not happening at a snail's pace either. Galaxies are moving away from each other at incredible speeds, driven by the mysterious force we call dark energy. It's as if the universe is a cosmic balloon that's being inflated, with each galaxy a spot on its surface moving further and further away from its neighbors. So when we talk about the size of the observable universe, we're talking about a dynamic, ever-changing landscape. It's a realm that is constantly reshaping itself, constantly growing, constantly surprising us. The observable universe is almost incomprehensibly large, and yet it's still expanding. Every day, every moment, the universe is growing, stretching the boundaries of what we can observe and challenging us to keep exploring, to keep learning, and to keep marveling at the wonders of the cosmos. Here's a mind-boggling fact. Our universe is constantly expanding. That's right, space isn't a static, unchanging expanse as one might initially think. Instead, it's more like a cosmic dance floor, where galaxies are constantly moving and shifting, sliding away from each other at incredible speeds. Imagine for a moment that we're all living on the surface of a balloon. As the balloon inflates, every point on its surface moves away from every other point. That's a pretty accurate analogy for what's happening in our universe. But what's causing this expansion? The answer lies with a mysterious force known as dark energy. Dark energy, which makes up about 70% of the universe, is causing space itself to expand. And as it expands, it carries galaxies along for the ride. The concept of an expanding universe was first proposed by Belgian astronomer Georges Lemaitre in the 1920s and was later confirmed by Edwin Hubble. Hubble found that distant galaxies are moving away from us in all directions, which led to the revolutionary idea that the universe is expanding. The speed at which the universe is expanding is known as the Hubble constant. However, it's not so constant after all. Recent observations suggest that the universe's expansion rate may be accelerating. If true, this implies that the universe's growth is not slowing down, but speeding up. So, what does this mean for the future? If the universe continues to expand at an increasing rate, galaxies will continue to move away from each other until they're so far apart that they're no longer visible to each other. The night sky, as we know it, would be dramatically different, with fewer stars and galaxies visible to the naked eye. As our universe continues to expand, its vastness only becomes more staggering. And while this might make us feel incredibly small, it also highlights the remarkable nature of our existence. We are, after all, part of this grand, ever-expanding cosmic show. So, how do we measure something as vast as the universe? This is where the concept of a light year comes into play. A light year is not, as some might think, a measure of time, but rather a measure of distance. It's the distance that light, the fastest thing in the known universe, can travel in a single year. Now, light is no slouch when it comes to speed. It zips along at a staggering 186,000 miles per second. In the course of a year, light can cover a distance of about 6 trillion miles. So, when we say something is a certain number of light years away, we're referring to the distance that light would travel in that many years. For instance, when we say our own galaxy, the Milky Way, is 100,000 light years across, we mean that it would take light 100,000 years to cross from one side to the other. That's a distance so immense it's almost impossible to comprehend. But these vast distances are exactly what scientists are dealing with when they explore the universe. The light year gives them a tool to make these immense distances more manageable. For instance, consider our nearest galactic neighbor, the Andromeda Galaxy. This galaxy is a staggering 2.537 million light-years away. That means the light we see from Andromeda today actually started its journey over 2.5 million years ago, when our ancestors were just beginning to use stone tools. By using light years as a measuring stick, scientists can start to map out the universe. They can identify where galaxies are, how far away they are, and how they're moving. Light years help us to make sense of the mind-boggling vastness of space. But remember, even with light years, we're still dealing with distances that are almost beyond comprehension. The universe is a vast place, and we're just beginning to explore it. Using light years, we can start to grasp the mind-boggling distances in our universe. Let's put this into perspective. Picture yourself in a spacecraft, traveling at the speed of light, the fastest speed possible as we know it. Now imagine setting a course for Proxima Centauri, our neighboring star. You might think, well, that shouldn't take too long, right? Let's see. At the speed of light, a staggering 6 trillion miles in a year, you'd still be in for quite a journey. Buckle up, because this trip is going to take you a little over 4 years. Yes, you heard that right. Even if you could travel at the speed of light, it would still take you more than 4 years to reach Proxima Centauri. This is because Proxima Centauri is located a whopping 4.24 light-years away from us. A light-year, remember, is the distance that light can travel in 1 year. So when we say that Proxima Centauri is 4.24 light-years away, we're saying that the light we see from this star today actually left the star over 4 years ago. This concept might be hard to grasp, but it gives you a hint of the vastness of our universe. Even our closest stellar neighbor, Proxima Centauri, is mind-bogglingly far away. And this is just the beginning. The universe doesn't stop at Proxima Centauri. No, it stretches on for billions of light years, filled with billions of galaxies, each teeming with billions of stars. So if you're thinking of traveling the universe, you'd better be prepared for some long trips. The universe is so vast that even the speed of light, the fastest thing we know of, seems slow in comparison. It's a humbling thought, isn't it? It makes our daily commutes, our cross-country flights, even our voyages to the moon seem like tiny steps in the grand scale of the cosmos. And remember, Proxima Centauri is just our closest neighbor. The universe extends much, much further. It's a vast, awe-inspiring expanse, and we're still only just beginning to explore it. One thing's for sure, the universe is a lot bigger than any of us can truly imagine. Want to see back in time? Look to the stars. Now, let's dive deep into the cosmos. The most distant objects we've perceived are not just a testament to the sheer immensity of the universe, but they're also a gateway to the past. How so, you ask? Well, these celestial bodies are so far away that their light has been journeying towards us for over 13 billion years. Yes, that's billion with a B. Let's break this down a bit. Light, the fastest thing we know, takes time to travel. When we gaze at the sun, we're actually seeing it as it was about 8 minutes ago, because that's how long it takes for its light to reach us. Now imagine objects so distant that their light takes billions of years to arrive. We're essentially observing these objects as they were billions of years ago. This is why astronomers often say that looking out into the universe is also looking back in time. It's like a cosmic time machine. Peering into the farthest reaches of the universe allows us to study the early universe, to witness the cosmos in its infancy. These ancient light signals are precious to cosmologists. By studying them, we can piece together the universe's history, understand how galaxies formed, and even get clues about the Big Bang itself. It's like the universe left us a breadcrumb trail stretching back to the dawn of time. So the next time you look up at the night sky, remember this. Every point of light is a story, a glimpse into the past, stretching back over the vast sea of cosmic time. The most distant objects we can see are the oldest stories, their light-whispering tales from the universe's earliest chapters. In a way, looking out into the universe is also looking back in time. So, how big is the universe really? The sheer scale of the cosmos is indeed mind-boggling. It's a grand cosmic ballet, with galaxies spinning and twirling, forever expanding outwards. To put it into perspective, imagine if our solar system were the size of a coffee cup. The Milky Way, our home galaxy, would be the size of North America. That's just one galaxy among billions in the observable universe. We, on the blue dot we call Earth, are but a tiny speck in this vast cosmic dance. Yet, despite our minuscule size, we've been able to peer into the farthest corners of the universe, uncovering its secrets and marveling at its grandeur. But let's not forget, understanding the universe is not just about size. It's about time, too. When we gaze at the stars, we're looking back in time, witnessing light that has traveled for billions of years to reach us. We're not just observers of the universe, we're time travelers, seeing the cosmos as it was, not as it is. In this vastness, where galaxies are our neighbors and light years our measure, it's easy to feel insignificant. But remember, we're made of the same stuff as stars. We carry within us the elements forged in the heart of supernovae, the remnants of stars long gone. So, as you gaze at the night sky, remember this. We may be tiny, but we're a part of this grand cosmic story. We have the power to comprehend the universe, to unravel its mysteries, and to marvel at its beauty. In the grand scheme of things, we're just tiny specks in an unimaginably vast expanse. But isn't it incredible that we've been able to understand even a fraction of it? It's a testament to the power of human curiosity and our relentless pursuit of knowledge. Our place in the universe may be small, but our spirit for exploration is limitless. To sum up, our universe is a place of mind-boggling size and scale. We've journeyed from our home, the Milky Way, a galaxy of stunning dimensions, stretching 100,000 light-years across. Beyond that, we've glimpsed the observable universe, a sphere of cosmic vision 93 billion light-years in diameter. We've grappled with the mind-twisting reality of an ever-expanding universe, with galaxies sprinting away from each other in this cosmic dance. We've learned about light years, the astronomical ruler with which we measure these colossal distances. And within this cosmic spectacle, we found our place. A tiny speck, circling an ordinary star, in the suburbs of a galaxy among billions. Far from making us feel insignificant, this highlights the incredible achievement of our species. We've managed to comprehend, even if just a fraction, of this vast cosmic spectacle. Thanks for joining this mind-expanding journey through the universe. Subscribe for more mind-blowing content.